Hello, everyone. Welcome to the DataPack EasyTrack webinar. The aim of this presentation is to provide you with a better understanding of how to use the DataPack EasyTrack systems when measuring coating processes. My name is Rob Hornsblow. I'm your presenter for this webinar. I'm the Senior Product Marketing Manager for DataPack Profiling Systems. The presentation is scheduled to last half an hour. And I'll start by covering the hardware components of the system, and then move on to some slides detailing how the Insight software can be used in optimizing your coating processes. But before we get to that, there's a brief introduction to DataPack, our global footprint, and our parent company. DataPack has been designing and building temperature profiling systems since 1984. We're the largest supplier of profiling systems in the world, and our team is specialized in this area as it's all they do. The company was founded in Cambridge, UK, and that's where the hardware, software, and electronic design team is still based, along with the product marketing managers. In 2007, DataPack was acquired and now operates as part of the Fluke Corporation. Our operating company within that group is Fluke Process Instruments, and that was made up when the three companies of DataPack, Raytec, and Ercon were brought together. As you can see on the slide here, Raytec and Ercon are specialists in infrared pyrometry, operating in a very similar industry segment to DataPack. Close to our heart is the coatings industry, as this was where our founder came from. Our founder and chief executive had been employed by International Paints prior to starting DataPack, and he had seen at first hand the problems caused when coatings were not cured correctly on products. Fluke Process Instruments has a global footprint. So as I said earlier, I'm based in Cambridge along with the R&D teams. Our manufacturing is based at the Raytec facility in Berlin, Germany. So products designed in Cambridge, manufactured in Germany. We have sales and service centers in Shanghai in China, and at our Fluke headquarters in Everett in the USA. Sales offices to support our sales personnel around the world are in Singapore, India, and on the northwest coast of the USA. DataPack divides the entire heat treatment industry into 6 segments. Today, we're going to be focused on the EasyTrack, which is used in the industrial coatings segment. And the easiest way of explaining that to anyone is always to talk about the coating of automobiles. It's something that everyone understands. Other industries we serve, high temperature heat treatment. For us, that's everything above 400 degrees. It's typically based around heat treatment of steels and alloys at high temperature. Then we have the ceramics and kiln firing segment. That includes heavy clay such as building blocks, but also includes fine china, porcelain, and technical ceramics. Food processing, that's obvious to everyone. It covers everything from cooking chicken nuggets through meat processing and fish curing. The electronics industry products are all based around soldering components onto circuit boards. The end products being anything from mobile phones through to anti-lock braking systems for automobiles. And finally, there are niche applications in solar photovoltaic manufacturing. Looking again at the coatings curing industry, we have 4 products. The Oven Tracker XL2 is a 2-part product, a 2-part data logger, should I say, that's aimed specifically at the automotive industry. The transducer interface can be left plugged onto the thermocouples, which are typically attached to a test car body. And this is a major advantage in that industry where the distance between the test piece and the PC may be hundreds of meters. It allows the operator just to walk backwards and forwards with the memory part of the data logger in their hand. The EasyTrack3 is the product we're talking about today. This is specifically designed for use in the coatings industry, specifically subcontract coaters, and meets the needs for day-to-day monitoring of that particular process. In addition to these two, we have our specialty oven systems, which are designed for use in more niche applications where space is very limited, such as coil coating, fabric processing, or beverage can manufacture. Finally, at the bottom of the screen, you see a reference to our custom systems. This is where none of the above can be used, and then we can use the expertise of our design team to create special thermal barriers tailored to a particular process. EasyTrack3 temperature profiling systems are delivered as a full solution, as you can see in the picture here. So we get data logger, thermocouple, software, thermal protection, and a carry bag. And then on the left-hand side of the slide, it calls out the main reasons or the main occasions on which people would use an EasyTrack3. First and foremost in everyone's mind is quality. It's proving that the process meets the coating curing specification, thus minimizing rejects and rework and preventing any product recalls. Productivity. Using a temperature profiler, an operator can match oven throughput to the throughput of the production line. Using a profiler of this type allows you to change line speeds and measure the effect on the curing schedules. Efficiency, setting up for new processes. When new products come into a subcontractor with maybe different thermal characteristics or varying substrate thicknesses, using an in-process temperature profiler allows you to set up the oven correctly for all parts of the product, thus achieving the curing specification. The data logger itself is the heart of the system. The EasyTrack3, designed specifically for this industry, it has a user-replaceable, commercially available battery, so you can just buy it at the corner shop, assuming they're open. It has a measurement accuracy guaranteed of 0.5 degrees. It maintains that over its operating range. A simple 3 LED status and stop and start buttons. Just one point on the batteries. If you have one of these loggers and you're in a situation where you're not going to be using it for a few months, as could be the case during the current crisis, then I would suggest you remove the battery from it. Batteries that have been heat cycled up and down in use, as typically these will be going through a process, could be more prone to leak, and you wouldn't want that damaging the contacts in there. So if you've got one and it's going to be on the shelf for a couple of months, take the battery out. All of the data is non-volatile, so nothing will be lost. The last profile one will be maintained, as will all the settings for the logger. The data logger itself is protected by the thermal barrier. It's probably worth me spending a couple of minutes on this. It's an important part of the system. The whole purpose of the thermal barrier is to reduce the heat input into the data logger, to reduce it to a minimum. So we have data sheets that tell you how long the barrier will protect the logger for at a given process temperature. The barriers themselves have a two-stage thermal protection system. So there's a microporous ceramic insulation, which reduces the heat input to an absolute minimum. And then there's the heat sink, which you can just see underneath the data logger in this image. It's a black, in this case, plastic container filled with a phase change material. So what little heat energy does get through to that central cavity is then absorbed as the material in that heat sink melts from a solid to a liquid, maintaining a very stable temperature for the data logger, which is always the best for accurate readings. For any electronics, likes to be kept at a stable temperature. A couple of points to note, and is often forgotten on these thermal barriers. You can see the over-center catches there that hold it closed. They actually have a small hole in them, and that can be used to lock them closed when in use. Now that's, it's useful when you're carrying them backwards and forwards. The catches don't come undone, but also they won't come undone during the process. And in addition, if these barriers have been in use, been dropped or been bent, then I would suggest you always place an R-clip, a simple R-clip through the hole, lock the catches. There's no chance of it coming undone in the process then. On to the next slide. A little bit about microporous insulation. And this will help those of you who are doing homeschooling at the moment in physics. We have three methods of heat conduction that we have to keep to a minimum. So the way this insulation is designed is that it will reduce conduction. It's a sintered material with small spheres, so they only have a point contact between the spheres, so conduction is minimized that way. Its sintered construction means that it traps small cavities for gas molecules, and that reduces the convection to an absolute minimum. So it's a compromise between density and conduction and convection. And so it's a very careful optimization of those properties to reduce the heat throughput. And then finally, to reduce the radiation, the spheres themselves are coated with an opacifier. All this is great. There is one point to bear in mind. The insulation can absorb moisture. It's generally not noticeable if you're using the system frequently, but if, as is possible, you're not going to be using it for a while, then when you first come to use it after 2 or 3 months, you may notice some condensate on the surface of the data logger. This is perfectly normal. It's the humidity in the air that's trapped within the insulation itself coming out on first use. So that may well be something that you hear about or run into in the next few months. Quick note on phase change. I thought I'd share this slide with you. This was a test we did on one of our thermal barriers at 110 centigrade, so it's quite a low temperature. The green trace shows the external environment temperature. The red one is showing the data logger. And you can see that in the first hour and 10 minutes, the logger raises from room temperature to 58 degrees. Then the phase change material starts to melt. And the heat energy coming into the system is essentially staying the same. The furnace is at 110 degrees. But for the next hour and a half, the temperature of the data logger doesn't change. But you can see that all that heat being absorbed into the melting of the phase change. After the 2-hour mark, the material has completely melted, and you see the temperature start to rise again. When we specify our thermal performances for all of the Datapack thermal barriers, it's specified at this point at the end of the phase change melting, and then that's what we give as the capacity. That gives us the safety margin on our specifications. So we've covered the data logger, the thermal barriers that protect it. Have a quick look through the thermocouples and some notes to bear in mind when selecting and using thermocouples. The thermocouples on a Datapack profiling system all use standard off-the-shelf connectors. So the thermocouples can be purchased anywhere, which is a great advantage to the end user. But take care when selecting thermocouples on accuracy specifications. The thermocouples we sell are to special limits of error, and it's this that's important. This specifies an accuracy of plus or minus 1 degree, or plus or minus 1.1 degrees. So it's this bit here that you should take care of when ordering thermocouples. If you don't specify that, the accuracy will be plus or minus 2.2 for type K thermocouples, standard versions. So a double in the uncertainty, if you like, of the measurement of the thermocouples. Our thermocouples for this industry have been developed over a long period of time. There's just some notes there that talk about the construction of the cable itself to try and provide the longest life possible for them. In terms of the measuring tip, for steel substrates, lots of variations on magnetic thermocouples, either with the measuring head right underneath the magnet or offset from it. Underneath the magnet's good, it's very repeatable. Offset from the magnet, you might want to do that if you're on a particularly light substrate where you're looking for a quicker reaction or response time. Thermocouples at the bottom there, you can see the two with the open junctions. These would give the fastest response time and would be used on very light panels. Typically, this is the sort of thermocouple that might be used in the coatings of beverage cans, where the thermocouple has been flattened to a thin foil and is stuck straight to the surface, where you're looking for very fast response times. As more and more aluminium is used in the automotive industry and in coatings, so aluminium window frames might be a good example. Magnetic thermocouples obviously cannot be used in that situation. There's a full range of clip and extended clip thermocouples to get to the middle of steel panels. And just one note before we leave the subject. I've been asked a question about infrared coating and infrared preheat sections in coatings ovens. We do have a range of thermocouples for use in this area. I would advise against PTFE as an insulation material here because the preheater, the emitter temperatures are very high. The PTFE insulation could get damaged and compromise the thermocouple itself. So typically you would use a steel braided thermocouple like the one in the image here, which has a very light tip pressed into the surface of the product to be measured. Typically with IR preheating, you're looking for a rapid rise in temperature, maybe tech curing, and you would need a lightweight thermocouple to be able to accurately measure what's happening on the substrate surface. One slide on thermocouple do's and don'ts. I'm hoping to reduce the number of phone calls that we get. On a thermocouple, the temperature is measured at tip, and this particularly applies to the patch type thermocouple, where when the thermocouple, if the tip gets damaged or broken, then there's a temptation to twist the wires together and take a measurement. This works very well if you understand that the temperature will be measured at the first point that the two wires touch each other. So if you twist together the wires and you do it over a nice long section of bare wire, maybe 25 millimeters, and then tape the end to the product, you may well be measuring something that's a temperature between the product and the air, because it will be measured at the first point where the two wires of the thermocouple cross. Now, in a very well twisted together wire, not an issue. If it's loosely twisted and as the thermocouples heat and go through the process, it could well be that first place they touch will actually move along backwards and forwards along the twisted pair, giving you a very odd result. These false junctions will occur anywhere on a thermocouple where the insulation's been compromised and the two wires touch each other. So misleading results you weren't expecting. The first place to look is along the length of the wire. Look for damage on the thermocouple. Okay, so we have a data logger that's getting us the data, the barrier that's protecting the logger from the environment. We talked about the thermocouples. A quick look at the software that's available. The software with EasyTrack3, available in 2 versions. The standard version is on the left-hand side of the screen. It contains everything you need to set up optimize, and report on a coating process. The professional version shown on the right-hand side adds to that the ability to have multiple pack files open at any one time, to be able to create process files and alarms. And typically this finds use, this would be with end users and powder coaters. The software on the left-hand side is probably better for the powder coater suppliers who are typically measuring different ovens every day. So professional, repeated measurements on the same oven, and the standard is just set up and no sort of long-term monitoring. Some features to call out: there is an auto detect feature on this software that's quite neat. It means that whenever you plug in the data logger straight to the software, running or not, it will run up automatically. You can print the calibration certificate directly from the logger at any time that it's connected to the software. So if you've been out working with an end user, you can provide them both with a profile that you've measured that day, also the calibration certificate from the logger, just to give the complete picture. So this is a typical report from a datapack profile run. What we can see here is that we're using the professional software. So the process manager has set up some alarm conditions. We can see in the top right, the operator has downloaded the information and immediately presented with a red light. The datapack value, which is a measure of the cure index, in this case has been exceeded on 3 of the thermocouples. Whilst we're looking at the graph, I can see this was done on a 5-zone oven. You can see the vertical lines on the graph here that denote the end of the zones. So if we're looking at a particular feature, maybe an overshoot in temperature, we can see that's happening in zone 2. We see immediately where it's happening in the oven. That speeds up our fault finding. Also on this graph, we've got this temperature trace running along the bottom here that barely changes through the process. That's the internal temperature of the data logger. It's normally not shown, but can be shown at any time. This process is particularly short. It's only 15 minutes. So the data logger barely changed in temperature through the process. The datapack value itself is a measure of the index of cure. The curing isn't just a simple time at temperature. It's curing will occur faster at higher temperatures, slower at low temperatures. And if we have 3 points with time, temperature, cure values, these can be entered into the software together with the temperature at which curing starts and the maximum temperature that the coating can be subjected to. Once that data has been entered by the process engineer, it's very easy when the operator downloads the information, software will automatically compare it to this value and give an indication of the cure of the part. Very important when you've got parts with a varying substrate thickness. So I think this example we just saw was a chair, where it was a metal chair with a large seating area, which was heating up much slower than the thinner arms. One thing on the software, there are a number of safety features built into the software that get forgotten from time to time, one of which is the ability for the software to check the internal temperature of the logger. I spent some time talking about how good the thermal barrier was. It can't last forever, and if you are setting up a process, it's very tempting to do multiple profile runs, one after the other. If you set up this feature within the software, it can prevent the logger from being reset if it hasn't had time to cool down. So quite a useful protection of the investment, if you like, against over-enthusiastic operators putting the system through quickly without allowing it time to cool down. As I said, the calibration certificate can be printed from the logger directly. This applies to systems that have been recalibrated at data pack calibration centers, where we use a software that will create a PDF copy of the cal cert, and it's in the data logger. So no searching around through the paperwork. When the auditor comes around, simply connect the logger up and you can print it straight away. Some of the earlier points I mentioned, on the bottom right-hand corner of the slide, remember, if you've got an old or damaged barrier and there's any chance of it coming open during the process, some simple R-clips through the holes will prevent the latches opening, protect your investment, keep the data logger cool during the process. To speed up thermocouple placement, they can be bolted together in what we call a thermocouple organizer, if you like. So if you've got a test piece where the thermocouples are connected to the test piece, you want to make sure you always put the same thermocouple into the same channel number so that you can compare one result to another. It's very easily done with a simple organizer clip. And at the other end of the thermocouple, if they're not attached permanently to the test piece and you're attaching them to a different workpiece every time, we do have a range of steel or metal labels that can be clipped onto the thermocouple wires so you can see which thermocouple goes where. Let me get back to my other screen. Finally, we do have an app available that allows, when people are sharing pack files, if you're on the move and someone sends you a pack file, it's amazingly frustrating not to be able to look at it on your phone. Well, we've dealt with that so that the data pack file viewer is now available on both Google Play and in the Apple Store. So it can be used on mobile platforms. This allows you to review. Thermocouples can be turned on and off. You can change threshold temperatures, so you can get a time at temperature functionality. It allows simple reviewing of pack files on the go without the need for a PC. Well, thank you for your attention. I hope all of you found something useful from the presentation. As I say, it was a brief introduction to the EasyTrack3. It's used in the coatings industry. Local RSMs, or if you want to contact us, are available to answer any particular usage questions you've got. If there's any questions relating to the webinar, then please use the chat to post your questions. And if there's nothing, then I thank you for your attendance, thank you for your time, and stay safe. Thank you.
Thank you, Rob. There's a question in the questions box for you.
Okay, so my question to you is, how do I see the questions box?
Okay, I'll just
if you can deal with that one, Ilya. I can see chats.
For measuring IR ovens, is it necessary to coat over the thermocouple because dark and light colors will absorb different heat energy?
It's a good question. It shouldn't be necessary to coat over the thermocouple. If the thermocouple is in good contact with the surface, with the substrate, and the thermocouple tip is lightweight compared to the substrate, then it will be measuring the substrate temperature rather than the temperature of the tip itself, as long as it's in good contact with the surface. So I would suggest using, a patch probe, the open junction thermocouples in that situation, certainly not the big magnetic ones. They will not respond correctly.
Okay.
Thank you.
We've got another question. Is it possible to have multiple runs, one after the other simultaneously?
Yes, the EasyTrack3 data logger does support multiple runs, so it can be reset. I believe 3 or 4 runs can be undertaken on the data logger before the need to return to the PC and download the information. In addition, there's a smart pack functionality on the EasyTrack3 data logger, so you can actually, when you reset it from the PC, set up the cure criteria, and the data logger will check the readings as it's proceeding through the process, so that when you open the system up at the end of the process and take the data logger out, there's an immediate red-green indication of whether the temperatures measured meet the criteria that you set up within it. So it can be multiple run, and it can also give an indication right at the end of the oven without the need to come back to the PC.
Yeah, thanks, Rob. And someone is asking if they can have the presentation.
Yes, I believe there's a recording being made which Leonardo will make available.
Yes, for sure. I can send out the presentation to all the attendees. Thank you, João Antonio, for the question.
Okay, thank you, Leonardo.
Okay, we have no more questions. Oh, sorry, just one more question came. Are there different sizes of the thermal barrier available? And what is the smallest size? I think this is for the monoblock. It's a question about the monoblock for cans.
Yes, there are different sizes of thermal barrier available. There are 4 that are specifically designed around the EasyTrack3. Typically for a monoblock process, the EasyTrack3 is possibly a bit too large, and we do have a smaller data logger and thermal barrier that's aimed particularly at that application. This is around the curing on cans. I would need to check on the dimensions for that. Maybe we can take that offline, that particular question. The smallest barrier for the ET3 is a TB37, and I can't remember the size. I believe
2037, yes.
2037. Can you remind me the height? I think it's 30 millimeters high.
It's about 30 millimeters, yes.
Yeah.
But the question is for the monoblock, and yes, we do have a dedicated system, as you said, for the monoblock, for the cans, and we can get in touch and send some information on that.
Yeah, we had a specifically designed very small data logger that uses some micro thermocouple connectors to reduce the logger size. I think it's down to 17 millimeters in height and 25 or 30 in width. So that was and is used with a TB0072 thermal barrier.
Yep. Yeah. Well, we'll save the questions and we'll get in touch regarding those with some data sheets.
That's for that one.
Yeah. Okay. There's another question. It's about furnace for heat treatment between 800 and 1000. What is the life cycle of the system or thermal barrier, and how many times can be used daily?
The life cycle of the thermal barriers will depend very much on the exact nature of the process it's being used in, on the atmospheres, combustion products that could be in the atmosphere, whether there's high-speed cooling or gas quenching. So I think we would have to take that question and deal with the specifics offline. But yeah, our systems are regularly used at temperatures up to 1000 degrees. And there are systems out there that have been in use for in excess of 10 years. Now, it will depend on frequency of use, and as I say, exact process conditions. So I think if the person asking that question gets in contact with us direct, then we could advise on that.
Yeah, of course. And it also, yeah, as you said, depends a lot on the application, on the atmospheres and the cooling media and cooling rates.
Yes. And the EasyTrack3 is not something I would recommend for use in that particular application either. Between 800 and 1000, I would be looking at a more robust data logger. It's a steel cased item.
Okay, I have no more questions, but we still have 3 minutes, so we can give a few minutes if you want.
Well, we can let everyone get 3 minutes of their time back, and if there's no more questions, then I think what we'll do, I'll make the slide deck available to Leonardo so that he can share it, and I believe he will also be making the recording, as it says on the screen, available up on our website soon. I will remind everyone, particularly those of you who are mobile, that to download the DataPack viewer. The viewer for the Apple is very hot off the press. I think that only went up on the Apple Store this last weekend. The Android version's been available for a few months. So please download those, and I hope they prove useful to you in time saving. Okay, if there's no more questions, then I think it's over to Leonardo to close the session, and I thank you for your time.